Well, good morning, good afternoon, good evening, good night, maybe, depending on where you are in this lovely world. Thanks so much for joining us here live on Serverless Office Hours, streaming on the AWS Twitch channel and on Serverless Land YouTube, and also via LinkedIn Live. Well, my name is Julian Wood. I am a developer advocate for serverless at AWS, and today I'm super excited to bring on three experts. So we're going to be talking about more front-endy kind of stuff. So Luca, I know you're also based in London. In fact, one of the cool things about today is finally the UK has got a complete takeover of office hours. So we've got three of us in London and Steve in Scotland. So it's taken a while, but we're eventually here. Apologies to our American, Australian, Indian, wherever else friends, but we're earning it today. So yeah, Luca, you're a solutions architect. You're an expert. You're a book writer on front ends. Yeah, tell us about your journey to AWS and what brings you here today.
Yeah, hi everyone. So my name is Luca. I joined AWS 2.5 years ago. After 7 years being a customer, I said, okay, why not joining AWS and trying to make the history with them. I loved so much the services, especially serverless, so I thought that was a good fit for me. And after a year and a half in AWS, I joined the serverless specialist team in EMEA, and currently I'm part of them. And on top of that, because I'm a self-learner, I truly believe in the sense of community. So I'm contributing a lot with my activities on the community, in doing public speaking, writing books, articles, and creating like POCs like we are seeing today. So yeah, try to, let's say, pay back my forever debt with the community.
You certainly are, and that concept of spare time is bizarre to me, but yeah, you're amazing. So thank you for all the stuff that you do. And Matteo, also completely other side, originally from Italy, as you'll hear from a lovely accent, but also based in London. Matteo, yeah, how long have you been at AWS, and what do you do? I see you're in for 8 years as part of the solutions architect engineering. What does that mean?
Hi, everyone. Nice to meet you all. I have been in AWS for about 5 years, always on the same team. SA engineering is one of the types of solution architects we have here at AWS. We focus on customer kind of engagements, usually involving development of solutions. For example, the development and release of demos, solutions, and code samples. And what I like, obviously, is software development. I've been here for about 20 years, a couple of decades now. I've been also a big fan of serverless for a long time. One of the actual reasons that actually motivated me to join AWS was to learn more about it and to get my hands dirty with it. So I'm super excited to be here today and happy to join the stage to basically share the stage with Luca, Steve, and you.
Excellent. Well, thanks for joining us. Yeah, Steve, I mentioned earlier you're slightly further north in Edinburgh, but yeah, welcome to Serverless Office Hours. What's your journey to AWS?
Thank you. Yeah, development is kind of second career for me. So I was in the military until my mid-20s, and then kind of got into development and then AWS, and sort of for quite a long time, I've been working in the serverless space now. I remember when I first used Lambda, you could only use Node 0.6. So yeah, it's been a while, and then yeah, moved into Matteo's team last year. So.
Excellent. Well, so just looking back before we come back to our topic for today, last week on AWS on Serverless Office Hours, we talked all about Lambda again, but it was all about power tools for .NET. If you're doing any development in a whole bunch of languages from .NET, obviously, as we talked about last week, but even Python, Java, TypeScript, and Node.js, Lambda Power Tools is an awesome suite of utilities. And so last week, there was a general availability release of Power Tools for .NET. So a whole bunch of observability stuff. And Amir and Henrique went through all the different kind of things you're going to do. Saves time in your coding, brings in all the well-architected goodness for your .NET Lambda applications. So certainly take a look, and that's available on our Serverless Land YouTube channel, along with all our other previous streams. In terms of what's new, last week we spoke about a whole bunch of things for S3 that were coming out. So if they're of interest to you from private connectivity for on-prem networks to cross accounts, multi-region access points. So S3 was on a bit of a busy time, which we spoke a bit about last week. So use the QR code or the link to read all about that. And then even more recently, SNS has support for setting the content type request headers for HTTPS notifications, which you can then use on the receiving side to know where those requests came from. So useful stuff in terms of serverless blogs. If you're into WebSockets and APIs, then Alexia's got a blog for you. If you're doing Java applications with Sam, then Mehmet, Steve, and Maximilian have a blog post for you as well. And also, we are going to be speaking to them, I don't think it's next week, but the following week on Serverless Office Hours. So see if you're into Java, mark that one on your calendar. And then some guy called Luca has also been doing a whole bunch of cool blog posts on micro-frontends, which we should probably talk about today. So let's get on to it. Often when we talk about serverless applications, it's a lot of back-end kind of things. We have some sort of snazzy front ends that we then connect to those back-ends. So I'm also fascinated about this whole concept of the sort of microservices and micro front ends and how you could do this with server-side rendering of front ends. So over to, Luke, are you first who's going to introduce us to it? Can be somebody else, but I think it was going to be you.
Yeah, that's definitely me. So let's start, first of all, with defining what micro-frontends are. I think there are a lot of misconceptions on micro-frontends, and setting the topic right probably is the key thing. So let's start, first of all, why we need micro-frontends. Because in the past, we were used to do this three-tier software architecture where we have maybe a single-page application, we have our application server, and one of the several databases that we have available in the industry. And it's absolutely fine as architecture. I'm still thinking that is a viable architecture. Sometimes when you want to have a quick turnaround and you want immediately see something in production, I don't discard it up front. But at some point, when you start to scale and prove that your idea works, you start to look at how to scale your organization and your architecture. And suddenly, the first thing that bubbles in your mind is distributed architectures. There are different kinds of architectures that you can express with in distributed system. One of them is probably the most famous, microservices. Microservice allows you to have independence between teams, and every team can choose the right tool for the job. So if before you need to design the entire information around the product and an organization with either a SQL or NoSQL database, now you cherry pick the right database for what you need. Same thing for the programming language. You might want to use, let's say, a low-level programming language because you have like heavy computation, and maybe stay more higher level with, let's say, more simple CRUD APIs that just need to query a bit of, I don't know, a NoSQL database. You expose usually everything on the API gateway, and that's your entry point for the front-end world. But usually what happens on the front-end world, when you start to migrate to this distributed system on the back end, the front-end developers are now still working on the same code base of before. There is nothing wrong with that, but there are some challenges, especially when you start to add more people into the teams, and you start to have, let's say, more complexity to add, more features, and suddenly a code base that was tiny and very coherent and cohesive start to become a big ball of mud. Usually, if you see in the history of software, very often when we have projects that are spanning across multiple years, the quality of the code is completely deferred to the capabilities of developers. And it's nothing wrong with that. But the reality is, when you have, let's say, a quick turnaround of developers inside an organization, or you are moving developers here and there across the organization, then the code base can have an impact on the quality of what you're doing. It becomes more convoluted to update. So with the same principle of distributed system, you can apply similar things and similar thought process on the front end, introducing micro-frontends. So the idea is quite simple. So like in microservices, you're using domain-driven design for slicing your monolithic system into small pieces that make sense and are bounded to a specific subdomain, and then more granularly in a bounded context. You can do something similar with micro-frontends. But let's try to see a definition of what micro-frontends are. So this is the definition that I coined probably in 2016 when I started to, let's say, share internally first, and then a few years later to the community how you should think about micro-frontends. And micro-frontends are a technical representation of a business subdomain with independent implementation. They can use same or different technology, and they are minimizing the code share, and finally they're owned by a single team. So in this definition, you can see that there are several highlights. So let me show you a couple of things before we move on. So here,
Luca, do people think of these as microservices? In terms of a backend microservice, is this the big picture, a front-end microservice? Or is that mixing up the terminology?
No, I think he's correct. The term micro-frontends is coming exactly from microservices. And usually you assign micro-frontends to cross-functional teams. So they are developing a specific bounded context, and they have front-end and back-end. If you think about that, architecture is leading towards this, let's say, more encapsulated way to design everything. Because if you think before we had microservices, now we have micro-frontends, but also we have data mesh. And if you think about that, having micro-frontends, microservices, and data mesh is basically allowing a team to own end-to-end a domain that would be able to handle from the data point of view to what is represented inside the screen. That is an extremely powerful concept.
Yeah, no, I like the distinction also that you've got front end in the name over there, because the microservice is, can be the bigger picture of a bounded context, but to separate the sort of ideology of the front end and the back end, I think can be useful. I'm going to hand back to you, but I forgot to say, please remember we are live. This is Serverless Office Hours here. If you have any questions or comments, or let us know where you're from. We literally have the experts over here. So we will, if you have any questions about today's topic, please let us know. Back to you, Luca.
So the first characteristic of a micro-frontend is that we should look into it from a business point of view. And when I say that, is for differentiating from components. Very often, the first mistake that a team is doing or an organization is doing when they look into micro-frontends is overlapping the term of micro-frontends with component, thinking that a micro-frontend is no more than a component that is loaded at runtime. But the reality is different. The component by design is leaking its domain into the owner of the component that knows how to use the component. Think about, for instance, a button. A button is a component that has multiple characteristics. It can be, I don't know, having the label auto resize the dimension of the button based on what the label length is or the label size is. You can have like a different rollover state. You can have an action when something is clicked. But the reality is the component itself is a generic and abstract a piece of code that then is, let's say, put into context by the container of the button. And micro-frontend instead is, let's say, a self-contained element that doesn't need much of the context because it knows how to operate in the context and is very well aware that in order to be independent deployable has to contain everything inside itself. And that is a very clear distinction, because you might risk, if you think about components, that then you suddenly see a lot of those patterns, anti-patterns, like deploying altogether multiple micro-frontends. That means that something is not designed right. And it's similar if you think about microservices, when you start to deploy multiple services every time all together, because one change of one microservice will change the logic of the other. So those kind of things are clear signals that something is not designed properly. Now, the independence part is pretty key here, because what we want to achieve is independent teams, not only independent deployment. The deployment side, on the technical side, we can have a lot of benefit of deploying independently a piece of functionality, because now suddenly we don't have to do a big bang deployment with all the features in one go, crossing our fingers that everything is going to work. But we can atomically say, I want to deploy this portion of the UI or this portion of the service. And that is a clear, let's say, differentiator from components. The other thing is, very often when you read online, you can find the micro-frontends might be used for incorporating multiple UI frameworks. Now, despite you can do that, it doesn't mean you have to do that. The reality is you always have to think about your user, your customer. If you have, for instance, Vue and a React in the same application, maybe technically you can do that. Also in a single page application, potentially you can do that. Would you do that though? Because you are going to ask the user to have a slower ramp up of your website and downloading the resources when in reality it's just a nice feature for developers, but doesn't add any value to the user. And the same thing applies to the micro-frontend. So it's very important that you have a strategy when you think about micro-frontend that is, let's say, coherent and try to be respectful towards the user and having the user as a first-class citizen when you're designing, you're taking your design decision.
Now, I think if I can
go for it.
Say one thing, I think you pointed something interesting here. So all these in this initial part, we've seen a lot of things that we share with the microservices concepts. I would say maybe one big differentiator between micro-frontends and microservices is that the composition is slightly different. Like microservices somehow are, if you want, kind of enable us to design things in a way that impact the end user a little bit less. If I use Rust to write an API for a microservice and I use Java to write the second one, but they both have expose a REST interface, composing kind of making various calls to different APIs kind of allows us to reason about in a level of abstraction that makes the implementation kind of not really important. But on the front end, that is slightly different. The reality is some of the choices that we can make while kind of from a developer point of view, developer experience point of view, may seem kind of totally reasonable, they may actually have a cost on the end user's performance. So it's actually more important to reason about coherence and consistency, as Lucas correctly said.
Thanks for highlighting that. The other thing is minimize the code shared. So in microservices, one of the way to define the architecture is a share nothing architecture. Probably you have read in several books or articles out there. And in micro-frontends, it's similar. There are certain parts that cannot be avoided to be shared, like a login library or a design system. But you need to be clear on creating intentional sharing where people start to look into that and understand not only the technical implication, but more importantly, the, let's say, organizational implication. Because when you are abstracting something and you start to share across teams, you need to have a strong governance that allows you to easily upgrade and update your code. It's not an easy task. And last but not least, the ownership part. I truly believe that today in 2023, we really need to have front-end developers that are capable to not only write some front-end code, but also operationalize their code, because they can really handle the important optimization for the code in order to provide the best experience for the user. That means basically that other teams can contribute to micro-frontends, but also it means that the team that is owning a micro-frontend, that is responsible for operationalizing in production, should be the last team or last person to say, yes, this code is going to be supported by us and is going to be in production. That is basically in a nutshell what micro-frontends are. Now, let's try to be a bit more concrete. Let's try to talk about a specific implementation that you might find out there. Now, this implementation is described in my blog series that Julian kindly shared before. And basically, the idea here, when I designed this, I wanted to show you that there are some key parts of an architecture that allows you to achieve, let's say, the creation of a server-side rendering micro-frontend application in AWS that is not too complicated. At some point, people start to look at all these icons and think, okay, but that is crazy. So here I tried to capture all the things that, in my opinion, are the cornerstone of a server-side architecture when you are not using a specific framework. This is completely framework agnostic. You can use with whatever you want. If you want to drill down into the implementation part, later on I will share also the URL for the code base that is already available on our AWS samples repository on GitHub. So the idea here is simple. We have a CloudFront distribution that is front-facing everything. All the static files are available inside an S3 bucket. What I mean for static files, usually in server-side rendering, you have not only images, but also some JavaScript that can be used for let's say, creating the interactivity for your browser. Usually in server-side rendering, you have this technique called hydration. That what it does is rendering a piece of HTML on the server, and then the hydration is taking care of plugging into the same DOM elements the interactivity that is loaded in a separate JavaScript file, and that's where basically the S3 it comes in. So we have all the JavaScript file needed for serving an application. Now we need also some way to compose our micro-frontends, because now we don't have only a simple template that is available for composing a micro-frontend. What we need is an application server that allows us to do a bunch of things. And in this case, I choose to use Fargate for the reason that I wanted to stream the content from the class Fargate cluster into the browser. The browser allows you to also interpret portions of DOM elements instead of buffering everything and then sending in one go the entire HTML. And in this
would this help with like type ahead and that kind of thing, because it's able to be a long running process?
Yes, it's not for the length of the process, because usually in server-side rendering, what it really matters is that it has to be fast. We need to be smart enough to apply the right level of caching in different layers. In this case, what we want to achieve is leveraging the streaming capabilities, because that usually, when you look at the website, you look at the core vitals that are the KPIs that Lighthouse and Web Page Test and all the other testing frameworks that are available online will use in order to understand how fast your page render. That
your time to first byte is that's your first interactive experience for your customers.
That's correct. And also are the key differentiator for your positioning, or one of the key differentiator for your positioning on search engines. Because the crawlers, they are looking also how fast is your page to be rendered. In fact, it's not a surprise that many retailers are using server-side rendering for having a better positioning, organic positioning inside search engines. Now, the Fargate has a clear task that is composing the micro-frontends. What it means? It means that we need to have a template with some placeholders, and then Fargate has to call a bunch of microservices that are serving, in this case, because I wanted to be agnostic on the framework, HTML fragments. And here the HTML fragments are served by AWS Step Function Express and AWS Lambda. Now, potentially what I could do is explicitly describing a template what is the URL for reaching the Lambda. But instead, I introduce a system parameter store that is part of the system manager that is acting as a service discovery. If you think about the pattern on the microservices, you have a system service discovery, because what you really wanted to do is decoupling the fact that my implementation by the IP of my service. So in this case, I query the service discovery service, and I ask for, I don't know, the catalog IP, and in this case, or DNS, and I receive that as a response. Then I can perform my request. Here is exactly the same thing. The idea here is that every micro-frontend, when it's provisioned in AWS, it'll subscribe with this ID and way to call it into the parameter store, and parameter store acts like a key value. So therefore, the Fargate cluster, what it does is reading the template, say, okay, I need the catalog micro-frontend. Perfect. So he knows that the ID is catalog. It's going to parameter store, retrieve the ARN, that is unique identifier for my Lambda or step function, call it, and you will receive basically an HTML fragment that is over there. Let me show you even more something that is even more interesting. Let me share with you the final example that I have. Let me stop for a second the screen. Let me share what is available here.
Well, while you are switching over, is it worth just, Rati, thanks for joining us via YouTube. If SSR is not required, could we not just have a single CloudFront distribution with origins for each micro front end?
The answer is absolutely yes. And if you're using client-side rendering, definitely, and we will talk about that in a few moments. I just want to show you the final, let's say, implementation. Let me see when you can see the screen.
Yep, we can see.
Perfect. So this is the final implementation that you can find easily inside. I will share the link later on. But as you can see here, this is a server-side render micro-frontends application, fully serverless, apart from having the cluster that we mentioned before. But all the rest is, let's say, loaded only when it's needed. And here we have three micro-frontends. The first one is the one with the green rectangle, where there is the product detail. The second one is the review one. So now the interesting, and we have a third one that is hidden, that is a notification system. So this simple example that represents the page contains all the, let's say, the main complexity around micro-frontends. For instance, if I click buy now, there is the third micro-frontend that is coming in. This micro-frontend is a simple alerting micro-frontend that is triggered when I click buy now, that is using an event emitter to communicate to all the other micro-frontends in the page that something happened. Like in event-driven architecture, what we want to try to have is clear decoupling between services. And in order to do that, you can use an event emitter, custom events, or even a reactive stream. Those are usually free techniques that you can use and share between micro-frontends for communicating with each other. So they can keep their state inside their boundaries, and they share only events with some payloads. Like in this case, as you can see, I see the title of the book and the price. The other one is even more interesting. So this one provides interactivity. So I can add a review of the product. So in this case, I would say serverless LAN title, and I don't know, this is a great product. Review 5 stars, submit. And this part here basically is handled by an API gateway that is completely decoupled from the others. So there is a team that is responsible for the reviews, but they are not only thinking about designing the reviews on the UI side, but also the API used by the reviews. So if you can think about that team is completely independent for doing so. And therefore is a fantastic way that you can handle, let's say, the scaling of your organization, because you can use these different technologies. Now, there is one thing that I want to highlight. The reviews micro-frontend is simple, a Lambda function with DynamoDB. So as you can think about that, it's quite easy to think how it would work. But the interesting part is this one, the details, a product details one. Because here we are using a step function express. In step function, you can have the standard and express version. And the express version allows you to work synchronously. So you can call it and have a response back, like you would have with the Lambda function, right? So in this case, what you do is using and leveraging a step function for generating the HTML and even caching in a DynamoDB table the final result, because this page is not going to, this micro-frontend is not going to change every day. Probably it will change few times in the first few days, maybe that is deployed, but then it's highly cacheable. And you can cache at the let's say at the beginning of your let's say implementation with step function. I can even show you how it looks like.
So step function is doing the generation of the page and then storing that in HTML in Dynamo?
That's correct. It's just an HTML fragments. Therefore, it's a very simple. Let me close this. Probably it became bigger. Render graph, and here you have how it works. So the first thing
we still see the screen.
Yeah, we still see the book. Yeah.
Oh, sorry, my bad. Sharing. What is it? Sharing here. Stop sharing. Present. Share the screen. Let's share the entire screen. So probably it's easier to move between pages. Okay, so you should be able to see it, right?
Not yet. We haven't got a shared screen popping up.
Not
The
yet?
remnants of technology. It's nothing to do with front ends, I promise. That's why we live.
Let's try again. Better?
There we go. Well, we've got a step function state machine, yeah.
Perfect. So this one, for instance, is the logic, right? So consider it's highly cacheable. I can cache in a DynamoDB. So the first thing that we do is checking in DynamoDB if there is an entry for that product. If there is no data, I retrieve the data from another Dynamo table that contains the data product. I render everything, and then I cache before serving the final HTML fragment. Otherwise, that is the best case scenario, I return directly the cache page. And that is extremely fast. It takes, when I did some trials, it could take up to 50 milliseconds just to have the entire thing already, let's say, computed and merged with data. And it can be shipped straight away to the UI composer that will take care on making the final page for the customer. As you can see, is let's say, a different way to think about using step function and step function express with synchronous invocation. And I think is pretty cool because you can describe a lot of those patterns just with the ASL or the Amazon State language. Whereas you can see here on the left of my Visual Studio Code, I describe how to retrieve the item from DynamoDB or when to call my Lambda function and so on and so forth. So the code that they need to maintain is really, really tiny. So less tests, less possible errors that are introduced by human beings. Is literally just configuration, if you want, and that is
so you're using the step functions, the SDK integrations, to read and write from Dynamo. And yes, if you need a Lambda function to do something more custom, you can have that. But yeah, that super powerful SDK integrations, yeah, it just means it's, you know, it's some JSON configuration that's really never going to go out of date.
Exactly. And it's super fast because I don't have to spin up any computer or anything. I just literally have to retrieve the data from Dynamo. Now, I want to catch your attention on another thing, and I pass the ball from now on to my colleagues around this parameter store. That is the easiest way to create a service discovery for micro-frontends. But there is more. We really think in the micro-frontends community that there is something that we are missing. We did a great job on the, let's say, composing micro-frontends on client side or server side. We did a good job on defining what micro-frontends are, but the deployment part and how to retrieve in multi-environment strategy micro-frontends was a challenge. And therefore, with Matteo and a few other people, we started to think how we can possibly solve. And I leave to you, Matteo, to let's say, go ahead and explain this.
Yeah, Matteo, no, thanks for that. Just before jumping in, because I know we do have a pause, I just want to, because there have been some questions that have come in. Let me just go back, and I just want to cover. And some of them were from the beginning, and of course I lost it when I did have the. Yeah, there were two other questions in the beginning, which was just about the micro frontends when we were discussing the original. One was, Pavel, thanks for joining us via LinkedIn, and that was thoughts around module federation. Yeah. And there was another term, which was in another question. Thank you for the Tech Guy 21, and then old portlets concept. So those two kind of things, what's the sort of terminology with those?
So portlets were the primitive implementation of micro-frontends. I agree with you. They seem like that. Then it was evolved to iframes, if you want to call evolution. And now we have a more, like Matteo is used to say, modern era of micro-frontends, where we have better tools like Module Federation. Module Federation is a Webpack plugin that is available with when you download Webpack 5 onwards, and that allows you to do federated modules. Therefore, you can take a portion of remote JavaScript somewhere in HTTP endpoint and then stream into your application. That is extremely powerful concept because it allows you to create micro-frontends, but not only, can be used also in your Node.js application. It's absolutely, the developer experience for me is fantastic of Module Federation, especially for client-side rendering part. And definitely we are going to touch up also Module Federation in a few seconds.
Cool. And then just the last one before we do carry on. The Tech Guy 21 again, thanks. Best practice for broadcasting between the micro frontends or communicating between them. I suppose that's all handled in the Fargate part, or is that on the client, or which is on the client side?
Is on the client side. So the communication usually happens, many people are thinking a global state manager will help, but in reality, you are creating coupling, and this design time coupling, as is called in microservices. Here we are talking about decouple the microservices using an event emitter, or using reactive streams, or custom events that are native in JavaScript. Those three options are usually the good ones when you are looking on how to communicate between micro-frontends.
Thank you.
Matteo, up to you.
Sure. Thank you, Luca, for the introduction. So I think that, as Luca said, when we reason about micro-frontends, both on the, it's kind of a word that is evolving very quickly. If you want to think about complex front-end architectures, they have been there for many, many years, and many kind of implementation have been adopted over the years. I would say also a lot of frameworks are around, frameworks that allow you to do multiple things. Front-end frameworks, for example, to allow sharing of components, tooling like module federation, cloud providers like AWS, and kind of make available serverless services that, as Luca just showed, allow us to put together something very powerful in a very simple way. But in a way, there is probably a problem that we, by speaking with many, many customers and operating in the micro-frontend world for many years with Luca, we observed is there, and it's kind of affecting every implementation that we've seen. And that's basically the discovery kind of side. If you think about microservices, there is a pattern that has been there for many years, which is kind of service discovery. Service discovery is a solution for handling communication between microservices, and and basically regulate deployments and releases. When you have discovery in place, you can actually improve your operations by, for example, introducing new release strategies, and such as canary releases to, for example, gradually release changes and reduce scope radius when you have issues. Also implement automation, for example, to handle inefficiencies or service degradation, and automatically react to problems. We tried to sit many months ago, and we realized, what if we tried to apply the same pattern to the front end? If you think about it, we are talking about distributed systems, as we said before. We are talking about systems that somehow need to be aware of each other. It's a system that are highly decoupled, both in terms of technological implementation, but also in terms of team ownership. So in theory, it seems like a perfect candidate for something like a discovery pattern. The idea really is there are, as you can see from the internet, many frameworks and tools available today. We didn't want to create a new tool that could kind of solve all the problems of micro frontends, because micro frontends today are a solution that is kind of approached by people with using many tools. But we wanted to actually create a pattern that could apply regardless of the tool and the frameworks that you adopt to do micro frontends. So in order to kind of create something that could be generalizable and generally available to many people, regardless of implementation, we decided to create kind of a regular meeting with a number of contributors from the open source community to actually come up with a standard that we could adopt and implement in multiple frameworks. This group kind of met every month. It was me and Luca, it was Zach from, which is the creator from Module Federation, or Web Backend Module Federation, and also Joel, the creator of Single Spa. And we actually came up with a schema, a design that could actually be implemented by multiple frameworks that could be somehow tech in the kind of flexible and also very portable, but that could obviously be used also when designing and architecting on AWS. And basically, this idea is about having a tooling that basically creates a manifest that kind of has the awareness of all the microfrontends that are releases in an environment, and allows also other microfrontends to discover other microfrontends when, for example, creating a user journey and, for example, rendering the path that a user is going to follow when clicking multiple buttons or navigating a large website that is composed by multiple microfrontends. And the idea was also to have something that will be agnostic of the of the kind of rendering mechanism. So that's something that will work both on the client side, but also on the server side, and possibly also something hybrid, for example, going through the edge. I think that was kind of a little introduction, Luca. What do you think? Obviously,
Yeah.
we can talk a little bit about more about that, but maybe we also have a couple of examples. We can show something,
Yes.
and maybe then we can take it from there.
Okay, so can you see my screen, right?
Yes, we can.
Fantastic. So as you can see here is a very simple React application. I just downloaded that like a default template, a free template you can find online. As Matteo said, it's completely independent. So it's it doesn't matter which is the framework you're using or whatever. This is the version 1, and the solution that we built was around creating not only the discoverability of micro-frontend, because if you think of working multi-environment, I have seen, let's say, several techniques, some of them very opinable, but let's say several techniques that allows you to load a dynamic URL with module federation. This is an example that works with module federation, for instance, but with single SPA as well, and so on. So now we wanted to create something that is easy, and in this example that is using module federation. So if I reload for a second, you will see this dot 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 dot, and then we'll load. That dot 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 will be the loading, but I'm not a designer, so sorry about that. But it would be the preload of our micro-frontend. And then we want to deploy a new version. But vast majority of the time, I have seen hundreds of companies that are just deploying, overriding, or creating a new version and deploying in big bang fashion to the customers. In our case, we created this, let's say, API that allows you to, there are a bunch of APIs. In our case, we have this API that allows you to, let's say, deploy a new version using canary release. Here you have linear 10% every 1 minute. So basically it means that it's adding 10% of traffic to the new version every minute. You can have, let's say, different time frame. You can deploy even all at once if you have to fix a bug in production, no problem at all. So now if I click send, this should, let's say, have a deployment request. Perfect. So we now deploy the new version that is already available and deployed in an S3 bucket. So now slowly but steadily we will see these. We still see let's say the previous version, and then in the next few minutes we are going, before the end of the serverless office hour, you will see the new version. There will be a different background, etc. I don't know when I will enter in the bucket of the new version, but that's the beauty of this approach, because the reality is we are trying to simplify and reduce the impact. Imagine that you have like a decent observability dashboard in front of you. You are basically awaiting that this deploying is increasing and covering all your users, but in the meantime you find a bug. So you can even block the deployment and roll back quickly with a tiny impact in production with only a percentage of your traffic. And that's basically what we had in the distributed system for the backend till today, but we were missing completely in everything that is a single page application, static site generators, or micro-frontends on the client side, and potentially also on the server side. Why not? So that's one thing that we really think was an undifferentiating heavy lifting that we can take and make it a simple example that can work with any automation pipeline. Either you're using AWS services or you're using, I don't know, Jenkins or Circle CI, whatever, because all the APIs to communicate with this system are an API away, a curl command away. That is amazing if you think about that.
Yeah. Just I wanted to maybe dive a little bit into how this works for maybe someone that may be not super familiar. This is basically what we are seeing here is a client-side rendered app. We call it shell app. It's basically a container that knows about a micro-frontend to be rendered inside. And in this particular case, is querying what we call consumer API for the discovery. Is saying, I want, for example, the product micro-frontend. I want the on-page micro-frontend. I want that thing. Give me kind of the URL that I need to actually load this. And so basically, I would say the trade-off that we are kind of talking about here is when I do the initial rendering, I need to basically consume the discovery service to know where to find the content that I need to render. But the cool thing about that is that as soon as I need to release a new version of that micro front end, the new consumers of that API are going to be kind of getting a new URL. And the cool thing about this approach is that when we reason about deployments with this in mind, we can see about something that just looks about shit, that basically looks just as a traffic shifter. When we want to, for example, release, it's just about switching to a new URL. We want to do a rollback rather than maybe redeploy a big bang application and wait for 10 minutes. We basically just need to switch to the old URL. So actually a rollback in case of incident could be actually happening in 1 second. If I have, for example, in AWS terms, a CloudWatch alarm that is connecting my website to monitor system or business metrics, for example, revenue for an e-commerce, or for example, performance on system metrics, I can automatically call the API to undeploy the new release after maybe it was rolled out only to 10% of my users rather than 100%. This means that if I'm impacting revenue, I may be impacting only part of the revenue of my business rather than 100% of it. And I'm gonna stop talking now because now we can just see these two.
I might jump in here a little bit. So if you're really eagle-eyed, when Luca posted the deployment, you might have spotted the linear 10%. This is I kind of stole this idea from AWS SAM. This is the exact strategies that you get from AWS SAM. And what this is effectively doing is it's doing the traffic shifting in a very similar way to what would happen with Lambda version or alias shifting. So it's kind of working the same way. That's kind of what it's doing. And one of the interesting thing about this that I think we talked about step functions earlier is we actually orchestrate the deployment through step functions. And what we do is when we initiate deployment, we calculate all the states that we need. But if you really think about it, what's happening there while we're doing the deployment, we're not trying to package anything. We're really just kind of waiting for most of the time. We're waiting, then shifting the percentage, waiting. And step functions seem like an obvious choice to me because you don't have to pay to wait effectively. So it's kind of a step machine that basically just iterates through an index of states and applies those states until the deployment is complete.
Yeah, in the meantime, we have the new version that is deployed. I enter finally in the percentage of people that can see the new version. Again, I'm not a designer, so don't judge. But let's say in this case, we just is going ahead for around a few minutes to go 100% towards this version. But as you can see, the tool is very simple and is available already on AWS Labs. So for the Matteo and Steve spend a lot of time not only let's say implementing this part, but also documenting this part. So you have a very let's say smooth journey for let's say deploying this solution into your AWS account. Here, as you can see, you have the template link to the CloudFormation that you can deploy in your account in whatever region you want, or you can directly click one of those links to launching directly CloudFormation with the template, and you have basically a set of APIs that are available to you today and are all described inside this nice repository. I think, Julian, can you share the link?
Yeah. I have put up the link. I had it before. There we go. There's the whole GitHub repo with everything in there.
And if you are into few client-side rendering application, as you can see, there is the example folder with module federation, single SPA. Both of them are starting from the basic dynamic implementation of micro-frontends that are available in their official websites. We presented this solution also to the creators, because we are quite close to them, and they are quite enthusiastic. So this is, let's say, a good testimony that, let's say, the micro-frontend community, it works together in order to achieve, let's say, the benefit for the community that I'm really proud and happy to see, because it's a huge effort for all of us, but it's extremely rewarding.
Now, thanks, Luca. One question I do want to pick up on, Neil Stewart, thanks for joining us via LinkedIn. MF is interesting. Understand why it can be beneficial. wondering whether this could be an appropriate approach, as it seems to assume a deeper understanding of AWS services and having a lot of additional infra, such as step functions, just to provide the front end. So I'd like to get your thoughts, obviously, on this as well. But from my perspective, as a novice on the front end, I think there's sort of two parts here. One is and I appreciate the step functions was used to generate the HTML, which was previously then cached in DynamoDB. But I think part of this is using a real sort of cloud native approach. One of it is you don't need to use step functions. You could use anything to basically generate and cache stuff in DynamoDB. Step functions is just a good serverless service to use that. So I think from my novice understanding would be the whole micro frontends is important and useful. And I think maybe in your mind, Neil, is not to get too necessarily bogged down with the deployment part of it, which uses step functions, or this cache generation part of it, which uses step functions, or in fact, any other AWS services that does sort of admin side on the back end rather than the front end side, which is just pulling together things. Is that am I on the right track?
Totally. And I would add one thing. You have to think about this not like one team building all this stuff, because it would be pure madness for doing for one team. But you need to think the micro-frontends are a solution when you have multiple teams that are working together in the same solution. Therefore, the step function part, it will be owned by a single team that is responsible for the API and for the generation of the product details, and maybe other micro-frontends. It depends how much scope you want to give to that. And another team is taking care about another part. So those are the cognitive load for every single team is very tiny. And here is just shifting the modularity that you usually express via code into infrastructure that is helping you to simplify certain practices. Like, for instance, we were mentioning step function that you can leverage the AWS SDK integration for retrieving immediately some data from Dynamo without spinning up any code, without doing testing, without doing a lot of things that usually you would do if you write code. And that have a direct impact on your CI/CD. You have a direct impact on the time that developers has to spend for dealing with this stuff, because reality is we are not looking at what are the hidden costs of our teams that are not only what the AWS bill is, but is more extended on where they are investing their time.
Yeah. And in fact, as you talk about the costs, Neil did carry on talking about this would seem like a significant cost compared to client-side rendering via S3/CloudFront.
Not really, because it's cacheable also server-side rendering. Depends how you structure that. You can have, if you have like static pages that are, let's say, have some, for instance, this is a classic example that I always ask by customers. Imagine that you have like a page that has a portion of the page that is personalized. So in that case, you can have do a server-side render of the static page without the personalization piece, and handle the personalization piece with an API that is, let's say, delegated to the personalization that is not cacheable and therefore can be hit and have different SLAs and different architecture, and doing that after hydration of the client side. So therefore, in this case, what happens is that the client first receive immediately something to see for the user, and when finalized to load just the portion to iterate of the personalization bit, it will start to load and query the personalized API that is available and start to render that. So now you have a two-phase iteration that is usually called also partial iteration, if you want, in the server-side rendering world. And there are, let's say, several benefits of that. If you think about that, there are, in the micro-frontends world, there is, let's say, this concept of Highland architecture that is getting more popular. There are frameworks that are leveraging that, and company like Etsy, for instance, that is came out publicly that are using a partial iteration for just iterate part of the page that is viewed by the user in order to optimize even further what you want to do. So now, yes, it makes more complex, but again, you need to think that these complexities spread across multiple teams that now have tiny portion to take care of and not the entire system.
Cool. We're going to do a quick fire because we've got some of the other questions. Sebastian, thanks for joining us via LinkedIn. Good practice to implement micro frontends at the page or business vertical level and not at the feature level. And how do you see the use of an external UI library to later be consumed by all micro frontends to achieve product consistency?
Matteo, you got it?
Yeah, I can take this one. This is actually a very good question because we spoke about components at the beginning also, and I will say that could be sometimes a little bit confusing. The idea really for micro frontend is a micro frontend is not necessarily something that goes in contrast with, for example, component libraries or design systems, or for example, mechanisms to actually share between micro frontends. The idea really is there is the actual macro front-end system usually is a combination of the two. The idea really is having two micro front-ends doesn't mean that they cannot use the same framework, that they cannot use the same library of components, that they can, for example, not have the two teams that can collaborate on the same design system. Still, when you actually reason about composition, so how, for example, they are going to go into the same page, you're going to need to reason about, for example, the fact that microfrontend A and microfrontend B both have the same dependencies. So if they both need to load React to actually be able to function in the page, or, for example, load a front-end library, they are going to need somehow to be able to be composed together. While it is possible to kind of package microfrontend A and microfrontend B so that each one has his own copy of the dependencies, the reality is that will be a cost for the user. So, for example, you could bundle 1 megabyte of one microfrontend, 1 megabyte of microfront B, and 1 megabyte of shared dependencies into a total of 3 megabytes. Or you could make microfrontend A to be 2 megabytes and microfrontend B to be 2 megabytes because each one has his own copy. What's the benefit? It's pros and cons. In 2 megabytes plus 2 means that the user loads an extra megabyte, but they can actually load different versions of the dependencies. The first one is better. You can actually get 1 megabyte less on the customer's bill if you think about the performance budget, but you're going to need probably team A and team B to be coordinated. So, for example, when one of them uses React 17 and one wants to upgrade React 18, they need to have a strategy for maybe upgrading together or stuff like that.
So as with all things, there are architectural trade-offs between and coupling questions that you need to do. And what I love about serverless office hours is when other people jump in and answer each other's questions in the chat. So Brandon, thanks for your comment as well. Yes, about using web components so they can be shared across different JavaScript frameworks. And Richard also pipes in. Richard Hess, thanks for joining us. Web components is the approach we've been talking about as well. There was one other question which we've probably got a minute just to chat about, and this was from Pawan Kumar. Thanks. If someone can touch upon micro frontends deployment best practices, and I know we use step functions as a deployment, but in the sort of general sense, what are sort of tips and tricks for that?
I think personally that the main issue we had so far was that we didn't have strong deployment mindset for micro frontends. I think the service discovery that we just presented, it shows the power of what you can do, because you have like the possibility to really, let's say, shape the traffic and reduce the risk that a bug will affect the entire code base. So if you combine that with strong observability, suddenly you have a very powerful system that allows your developers to see that what they are deploying also multiple times per day will be effective. When I started to see this kind of implementation and this safe net for developers, the developers' mindset completely changed. We moved from 4 or 5 deployments per month to 25 per microfrontends per day. And the reason behind that is because we went at the granular level, because there wasn't a tool. We had to build our own tool in my previous company. We built at the level that the developers could say, I want to release this in England only on Chrome, 5% of the traffic. And then suddenly they start testing production what they have written and have immediate feedback. Change wherever is needed, shift the traffic to 0 or 100% to the previous version, and then redeploy again. And that became very healthy because it provides, let's say, the throughput that developers are looking for.
That is perfect. We are fast running out of time. I'm just going to post up the GitHub repo again, because this isn't just the stellar talk we've been talking over here, but all of the GitHub stuff as well. Just before we say goodbye, next week, if you're into AI, ChatGPT, DALL-E, all these cool kind of things, and you've been in getting all the technology AI buzz. I'll be off, but Eric Johnson's talking to a colleague on my team, Dave Boyne, about doing a serverless event-driven approach to build a really cool bedtime story generator for your kids with stories involving their names and all that kind of thing. Super cool stuff. Of course, remember on serverlessland.com all tips, tricks, and everything you need to know about serverless and AWS. But thanks so much to Luca and to Steve and to Matteo for joining us today. I think we could have carried on for ages, but unfortunately we're running out of time. So we appreciate, and we'll certainly have you on again. But thanks for all the hard work for the GitHub repo and all the blog posts. And there's still more to come. And enjoy the rest of your week. But thanks for joining us. Thank you very much.
Thank you for having us.
Thank you.
Thank you.